prove by mathematical induction that this statement is true. It says R, the sum from R equal 1 to n of 2 plus 3R is equal to n over 2, 3n plus 7 in brackets. I'm going to ask you to pause the video and make an attempt at it and prove it. Okay, have you finished? Let's look at it. Now, here, what you're going to do is to start right from the first, all right? You start it out correctly. So, you're going to show that the proposition involving 1, it means P1, is true. In this case, R will be equal to 1, no, n will be equal to 1. Now, you have R automatically will be 1 as well. R equal 1, n equal 1. So you have 2 plus 3 by 1. So that's what you're going to have. 2 plus 3 times 1 is equal to 1 over 2 times 3 by 1 plus 7. This will be 2 plus 3 by 1. 3 by 1 is 3. 2 plus 3 is 5. Is equal to half times 3, 1 is 3. 3 and 7, 10. Half of 10, which is 5. So 5 is equal to 5. Therefore, the P1 is true. The proposition involving 1 is true. Now, let's talk a little bit more about this. Remember, here, oh no, yeah, pardon me there. Remember, what's going on here is this. You have, when R is equal to 1, you have 1. So 2 plus 3 by 1 equals 1 over 2, 3 by 1 plus 7, which we saw a while ago. Oh, you don't need to prove here or show that it is true when R is 2, or when R is 3, or when R is 4, or when R is 5, or when R is 6, and so on and so forth. In working this out, you're required only to show that it is true for R is equal to 1. But let's look at what happens when R is 2. Now remember, it's a sum. So when R is 1, and then R is 2. When R is 1, you have 2 plus 3 times 1. We're going to have 2 plus 3 times 1. That's when R is 1. And then it's a sum. Notice the summation sign. Sum from R equal 1 to n. In this case, n would be 2. Because you'll be saying this is plus, and then 2 plus 3 times 2. Now, n is the number where you stop counting. So n would be 2 in this case. Is equal to 2 over 2 times 3 by 2 plus 7. 3 by 2 plus 7. You just get a little understanding of what this is saying. So you would have 2 plus 3 is 5 plus 3, 2, 6. 6 and 2, 8. 5 plus 8 is 13. Let's see if the other side is also 13. Now, 3, 2, 6. What is 6 and 7? 13. This will amount to 1. So 1 by 13 is just 13. See that? Let's look at one more. What happens when R is 3? So we have R equals 3. What happened here? You'll be summing from when R is 1 plus, then when R is 2 plus, then when R is 3 equal. And 3 is where you stop counting. So N would be 3. So what you would have here is 2 plus 3 by 1. 2 plus 3 by 1, that's when R is 1 plus. 2 plus 3 by 2, that's when R is 2 plus. 2 plus 3 by 3, that's when R is 3. Would be equal to N is 3, so it's 3 over 2, 3 by 3 plus 7. So it will be 3 over 2, 3 by 3 plus 7. So 2, 3, 1, 3 and 2, 5 plus. This would be what? 2 plus. This should be plus. 3, 2, 6 and 2, 8 plus 3, 3 is 9, 10, 11 is equal to 3 over 2 times 3, 3 is 9 plus 7. Let's see how this would work. 11 and 8, that's what? 19. 19 and 5 is 24. Now what is this? Now you have 9 plus 7. 9 plus 7 is what? 16. 3 over 2 times 16, right? So 2 into 2, 1, 2 into 16, 8, 3, 8 is 24, so it worked. So that's just to illustrate what happened here. Let me just erase this. I won't erase the R equals 3 and so on. So you see, the value of R keeps changing, right? So R changes one step at a time. N is where you stop counting. All right? I'm assuming that you are not very much accustomed to this type of proof of a series, so I'm explaining all of this. All right, so here we have looked at step 1 here. Generally, this is step 1. You show that P1 is true. Now we're going to look at step 2. Right? Now, step 2. Assume that PK, that means the proposition that you're making here involving the number K, is true. Now what will happen? That N is equal to K. K is where you stop. So you're going to say the sum from R equal 1 to K of 2 plus 3R. So it's the sum from R equal 1 to K of 2 plus 3R is equal to K over 2. That's K over 2. 3K plus 7. 3K plus 7. All right. So why K? Now, K is not a specific number. if you show that P1 is true, right? And then you show that P2 is true, what would happen? Somebody now can scrutinize what you did and say, hold on, you show for 1 and 2, but what about 3? And if you show that it is 3 when you add up 1 to 2 to 3, then the question is, what about 4? You didn't show for 4. And the thing is, if you show for pk is 1, and then you show that it is true for k equal 4, somebody could say, oh, but you missed out 2 and 3. What about those? And 4. 2, 3, and 4. You show 1 and 5, but you didn't show for 2, 3, and 4. And even if you show for 2, 3, and 4, they could say, what about 6? So, k is not a specific number. So, anyone's argument that you didn't show for a specific number will not be valid because you don't know what k is. K could be 2, it could be 3, whatever it is. So, that is step 2 in this case. Now, it's necessary to show that k is true. But then, the next question is this. What about the next number? You show that it's true up to k. So, what about what happened after k? Whatever k is. Right? Just because you don't know what k is doesn't mean that you can use it to fully defend yourself or defend your argument and so you prove it. The question is, what happened after k? Alright. So we have to go to step 3 now. So that means we show that now the next number after k would be k plus 1. Show that the proposition involving k plus 1 is true. Alright. So in this case now, you're going to have n equals k plus 1. Now you notice I didn't say what r is, because r is not a specific number. It was 1 and then 2, and when you work it out for 2 and you add it to 1, then it's 3. You added what you have from 1 and 2 to 3, and then 4. You added what you have from 1, 2, and 3 to 4, and so on and so forth. It's a sum. You see the summation sign. So r is not a specific value. But n is a specific value because n is where you stop counting. If you want to count from 1 to 10, n is 10. If you're going to count from 1 to 20, n is 20. Counting from r equal 1 to 30, then n is 30. Wherever you stop, that's n. Now, the thing is, you stop at k. I mean k plus 1 in this case. So n is k plus 1. So what you're going to do, you say the sum from r equal 1 to k plus 1. So you have the sum from r equals 1 to k plus 1 of 2 plus 3r, 2 plus 3r. The r does not take on any specific value, right? It keeps changing, so it remains r is equal to, and on the right hand side you have n over 2. This is going to be k plus 1 over 2. So n is k plus 1, k plus 1 over 2, open bracket, 3 by k plus 1 plus 7. Use square bracket here. 3 by k plus 1 plus 7. Alright, so you change n to k plus 1. Now, you're going to have to prove this. But how do you deal with the left hand side? You're summing from r equal 1 to k plus 1. Alright? You don't have any specific thing here that says r equal 1 to k plus 1. You know that r equal 1 to k, this thing here, from r equal 1 to k of this, is this. So you try and get out r equal 1 to k from this. Alright. Now, one thing to note is this. The sum from r equals 1 to k plus 1 is the same thing as the sum from r equals 1 to k plus the k plus 1 term. Alright? Now, example. Suppose you say the sum from r equals 1 to 5. What is that? It is 1 plus 2 plus 3. So these are the values of r. When r is 1, then when r is 2, then when r is 3. Right? Let me rewrite it. So r equals 1 plus, when r equals 2 plus, when r equals 3 plus, when r equals 4 plus, when r equals 5. This is the sum. If you're summing it up from when r equals 1 to 5, but guess what? 5 is what? Oh no. What is 5 here? 5 is the same as 4 plus 1. Right? So, you're summing from r equal 1 to 4 plus 1 then. You see that? No, it's the same as summing sum from r equals 1 to 4. And then after that you say plus the 4 plus 1th term. Because each of these, is one single term. You're adding up. So if you add up the first 4 terms, you get something, and then you say, I'm going to add the term that comes immediately after this. You just take it and add it. Alright? So it's the same thing here. So what you're going to do, you're going to separate the sum from r equal 1 to k plus 1 into the sum from r equals 1 to k. Then add the next term, which is the 4 plus 1. The k plus 1, I mean, term. So that's a standard practice with this kind of mathematical induction. Alright, so what are you going to do? You have the sum from r equal 1 to k plus 1 of 2 plus 3r. We're going to sum it from r equal 1 to k of 2 plus 3r, and then add the k plus 1 term. So let's see what happens. Is the sum from r equal 1 to k. So we find the sum from r equals 1 to k of 2 plus 3r of 2 plus 3r plus the k plus 1th term. And that will be equal to the right hand side, which is k plus 1 over 2, k plus 1 over 2, and then in brackets 3. Let's start multiplying this out. 3 by k is 3k plus 3 once 3, so it's 3k plus 3. You have 3k plus 3 plus 7. You see that? Just multiply the 3 by what is in the bracket here. Alright. Now, here, you added the first term, plus the second term, plus the third term, plus the fourth term, plus the fifth term, plus the sixth term, and so on and so forth. And then you add the next term, the k plus 1th term. Now, what does each term look like? We want to see what the k plus 1th term look like. The first term, what was the first term again? It was 2 plus 3 by 1. It was 2 plus 3 by 1. The second term was 2 plus 3 by 2. Right? Because remember, you know, he said 2 plus 3r. First term is when r is 1. He said 2 plus 3 by 1. Second term is when r is 2. He said 2 plus 3 by 2. The third term is when r is 3. The third term you say 2 plus 3 by 3, and so on and so forth. Now, what is the k plus 1 term? What does it look like? Well, it's 2 plus 3 times the term. So it must be 2 plus 3 times k plus 1. You see that? Think about it. That would be the k plus 1th term. You see that? So we're adding up from r equal 1 to k of this. And then we add the k plus 1th term. Remember when we did the working out here, the first term was 2 plus 3 by 1 plus the second term 2 plus 3 by 2 plus the third term 2 plus 3 by 3. So the kth term would be 2 plus 3 by k, right? That would be the kth term, and the k plus 1th term is 2 plus 3 by k plus 1. Now remember, r keeps changing from 1 to 2 to 3 to 4 to so and so on and so forth. But the last number you stop adding up, and you see you're not going to add anymore, that number that you reach is n. In this case, it is it is k plus 1. Alright, now let's see what happens after this. Make sure you understand, you know. Follow carefully. I'm giving some detailed explanation of this thing here. Let's see what happens after this. We can't scroll down anymore, so I'll just draw this line and we'll work on the right hand side of the line. Now, here we have the sum from r equal 1 to k of 2 plus 3r. Let's rewrite it here. We have the sum from r equals 1 to k of 2 plus 3r plus the k plus 1th term, and we saw that the k plus 1 term is 2 plus 3, k plus 1. So you say plus 2 plus 3 k plus 1, and that will be equal to k plus 1 over 2. So that's k plus 1 over 2. Then you have an open bracket there. K plus 1 over 2 times, in bracket, 3k plus 3 plus 7. Well, this is really 3k plus 10, because 3 plus 7 is 10. So we're going to write 3k plus 10. Alright? So in the bracket, we have 3k plus 10. Okay. Now, we have a little issue here. We need to have this part written out, right? Plain and straight, just like the rest of it. What is the sum from r equal 1 to k of 2 plus 3r? Remember we saw it before. The sum from r equal 1 to k of 2 plus 3r is k over 2 times 3k plus 7. Alright, so we have it. K over 2, 3k plus 7. So this is k over 2, 3k plus 7. And then your plus 2 plus, you can just multiply what this, 3 times k, 3 times 1. So it's 3k plus 3 ones 3 is equal to, we can write everything here as k plus 1, 3k plus 10 over 2. Alright? Now, when it comes to this point now, if you're in a hurry like in exam and so, and you feel most comfortable with a certain method, you could change up both sides, could multiply everything by 2, open the brackets, right, if that's the quickest way. But a more sophisticated way is to change only one side to look like the other side, right? It shows a greater level of skill if you can do that, and it would be more impressive, right? Show that you would be operating at an even more advanced level, slightly more advanced level in terms of your algebra. But anyway, let's change up the left hand side to look like the right hand side. Now you have k over 2, 3k plus 7. This is plus 3k plus 2 and 3, 5. Alright. Is equal to, I don't need to keep writing the right hand side, but let me just write it down to keep track of where we are. Alright. Now this is k over 2, 3k plus 7. You know, you could write this as a fraction with common denominators, right? So if you have this as k times 3k plus 7 over 2 plus, this is 3k over 2 plus 5 over 2, but you have to multiply the top by 2. If you put this over 2, you have to multiply the top by 2. Remember your fractions, right? Multiply the top and bottom by 2. It's like the 2's cancel, or you multiply them by 1. Well, 1 common denominators. Before, you know, this was over 1 and this over 1. So you multiply the bottom by 2, you multiply the top by 2 too. Right? So 2 times is 5 by 2. Alright. Now when you have everything over 2, let me rewrite this. K plus 1 on the right, 3k plus 10 over 2. When you rewrite everything like this, everything would be over 2. Right? So what you would do is say k times 3k plus 7 plus 236k plus 5 2's 10 all over 2 is equal to k plus 1, 3k plus 10 all over 2. Now, if you look on the right hand side, you see the k plus 1, 3k plus 10. It looks like the result of having factorized a quadratic expression. So let's expand the bracket on the left and see if we can get a quadratic and see if we can factorize it. K times 3k is 3k squared plus k times 7 is 7k plus 6k plus 10 all over 2 is equal to the right hand side here. Alright. Oh, guess what? Yeah. I was about to say 7 plus 6 is 13. Right? But part of the factorization is already done. Just group them and factorize. So you say k outside this bracket, and you say 3 k plus 7 plus 3 outside this bracket, and you would say, oh, plus 7k. Oh yes, 7. So what you have here would be, let's see. Oh, it wouldn't be the exact thing. We have to just put it together and factorize it then. Put everything together and factorize. Oh my, we're about a part of the line. Alright, so we have 3k squared plus 7k plus 6k plus 10 over 2 equal that. So 3k squared plus 7 and 6 is what? 13, right? 13k plus 10 over 2 is equal to this thing that we have over here. 3k plus 10 over 2. And then we say we're going to factorize this part using the AC method. You see, if you had multiplied over the brackets on the left and the right, it would you would need to remember the AC method, but I wanted to factorize and show it. Alright. Let's see now. 3 times 30. We need to find two numbers that multiply to give you 30, and they add to give you 13. It's 10 and 3, right? So you could say 3k squared plus 10k plus 3k plus 10, right? You separate the 13k into 10k plus 3k over 2. And then factorize k outside the bracket. You have 3 plus 10. Oh, k plus 10. What? 3k. I mean 3k plus 10. Right. And then plus, what do we have in outside the bracket here? Well, it would be 1 outside the bracket. We have 3k plus 10 inside the bracket all over 2. So on this left hand side, we see that you have 3k plus 10 as a common factor. So you'd have 3k plus 10, and then you factor it out as k plus 1 over 2 equals, what was it on the right hand side? K plus 1, 3k plus 10 over 2, k plus 1, 3k plus 10 all over 2. Okay, it's the same thing. We can rewrite it if you want. 3k plus 10, k plus 1 over 2 is equal to 3k plus 10. You're just putting the 3k plus 10 first, putting it here. Same thing. k plus 1 over 2. So in that case, you prove it. So you can write y. Prove. All right. Now, as I said, use a factorization using the AC method to work it out. If you should come back here and say you reach this point, so you multiply by 2. I'm going to ask you to do it on your own. Multiply by 2, you get k times 3k plus 7 plus 6k plus 10 equals k plus 1, 3k plus 10. And then you multiply out all the brackets on the left and multiply out all the brackets on the right. You'll be able to show that it is so as well. But I just chose a more difficult but more advanced and sophisticated way. Just change one side to look like the other instead of changing up both sides at the same time to match. Alright, so if you change both sides at the same time to match, it's still correct. As long as your mathematical operations are correct, right? It will still be correct. Alright, so that's that for now.